first three terms of a geometric series are 4p, 3p plus 15, 5p plus 20, where p is a positive constant. I need to show that this is true. So remember, a geometric series is where we have a common ratio, where we are multiplying by the same number each time. So I can say that 4p multiplied by r is equal to 3p plus 15. I can also say that 3p plus 15 multiplied by r is equal to 5p plus 20. In this first equation, if I divide both sides by 4p, I can say that my common ratio is 3p plus 15 divided by 4p. And similarly with the second equation, if I divide both sides by 3p plus 15, I get a different expression for my common ratio. And because it's exactly that, a common ratio, I can make those two things equal to one another. And then I've got an equation to solve where I'm going to cross multiply. So I'll get 3p plus 15 all squared equals 4p times 5p plus 20. Expand the brackets out. And then move everything over to the right hand side. So 20p squared take away 9p squared is 11p squared. 80p take away 90p is minus 10p minus the 225. And that's what we needed to show. Part B. Hence show that p equals minus 5. Well, if I solve that equation, I find that either p equals 5 or p equals minus 45 over 11. P is positive, constant, therefore p equals 5. You can show this in different ways. You could factorise. You could complete the square. You could use quadratic formula. Several different ways you could use to show that those are your two solutions there. Part C, find the common ratio. Well, I had an equation for common ratio down here, so let's use that. So the common ratio, so 3p plus 15, if p is 5, that's going to be 30 over 20, which is 1.5, or 3 over 2. And then part D, find the sum of the first 10 terms of this series, giving your answer to the nearest integer. The sum formula is a times 1 minus r to the power n over 1 minus r. My a, the first term in the sequence, well, it was 4p, and given that p is 5, my first term will be 4 times 5, so 20. The common ratio we've just worked out, and n is 10 for the first 10 terms in the series. So 20 times 1 minus 1.5 to the power 10, all divided by 1 minus 1.5. And I'll just work that out quickly. And we get 2,266.6 to the nearest integer, so 2,267.